Hello. Can you hear me well? Yes. So hi everyone, my name is Guillaume. I'm a PhD student at EPFL in Switzerland, and I work on Dotty, which is this new compiler for Scala. And today I'd like to talk to you about the state of Dotty, which is still a research project, and like what we plan to do in the future. Thank you. So before I want to talk about Dotty, I will give a few words about dot, because this is the origin of the name Dotty, is dot. So dot is basically theoretical foundations for Scala. It's a set of mathematical statements about a very simple language, which is not Scala, but which has the core principles of Scala in it. And the important thing is that we want to prove that the type system of Scala is sound. Why is that important? Because if your program type checks, it should work fine when you run. Which means, like, for example, you don't want to have class cast exception if your program compiles without errors, and you don't use unsafe features like casts. So what is Dotty? So Dotty is a new experimental compiler for Scala that is developed at EPFL, and it has a very completely redesigned internals compared to the old Scala 2 compiler, which is inspired by the work on Dot, but externally it looks very similar. When you use it, it feels like Scala. So one of the great things of working on Dotty is that it means that we can redesign a lot of the pieces of Scala and make them better. For example, we have been working on making incremental compilation better, because in some cases, incremental compilation could forget to recompile some things, that kind of problem. And by redesigning these components from scratch, we have a chance to make them better. Another example is when you do pattern matching checks, you want them to be very strict and to not let you do anything. So we have a new checker that makes sure that when you do pattern matching, you don't miss cases, and it won't let you miss cases that previously could be missed. So, and one thing that's interesting is that some of these components may be reused in Scala 2 because they are not specific to the design of Dotty. So tooling. So as we all know, if you want a good developer experience, you need good tools. So for now, Dotty only has very few tools, but it's improving. So we have a REPL, which is slightly nicer than the default Scala REPL because we have syntax highlighting. And we have DottyDoc, which is a way to get documentation for your code like ScalaDoc, but it's a much redesigned system with simpler which is simpler and easier to use. And we have been working more recently on IDE support using the language server protocol, which means that instead of like adding IDE support for one particular IDE like Eclipse or IntelliJ, we are working on something that could work with many different IDEs which implement this protocol, and we have been experimenting mostly with Visual Studio Code. See Felix talk tomorrow for more details on tooling in Dotty, and I'll leave it at that for now. One of the interesting components of Dotty, which is still experimental, is the Dotty Linker. So the basic idea of a Dotty Linker is that if you do a complex analysis of your whole Scala program, including all of its dependencies, then you can do many global optimization on your program. So, for example, you can do dead code elimination. If you know that a method is never used anywhere, then you can just remove it from your bytecode so that your compiled file is much smaller in the end. Another one is automatic specialization. So instead of manually having to add specialized annotations to your classes, the compiler could automatically figure out what exactly is used where, and based on that, introduce specialization. For more details on the linker, you should see Dimitri's Scala Days talk. So the linker is still experimental and not part of Dotty itself, but we hope to be able to put it into Dotty sometimes in the future. So, speaking of the future, we want to do a first technology preview release of Dotty pretty soon. So this will not be a stable release, this will be like an alpha release. And the goal is to get feedback, to get people to try to use it, to try to compile their Scala project with it, and tell us what they like, what they dislike, and report bugs, because we need people to use it to find bugs in it. And meanwhile, Scala 2, as it exists, Scala C will continue to evolve for a long time. So what we want is convergence. Basically, we want on one side Dotty to be able to compile more and more Scala code that exists, which means that it needs to be tested with a lot of Scala code. And the other side, we want the existing Scala 2 compiler to be able to use the new features that we introduce in Dotty. So, for example, we are working in a compatibility mode in Dotty to use some of the deprecated features of Scala that are not present in Dotty. And on the other side, Scala 2 is starting to implement features like thread parameters, which I will talk about later, that are present in Dotty. So, migration. So some Scala 2 code may not work well with Dotty because we remove some features or because of differences in type inference, that kind of things. And we want to, as much as possible, make it easier for people to use their code with both Scala 2 and Dotty. So one tool which has been worked on now is ScalaFix, which it tries to automatically rewrite your code to ease migration. This is still very early, but the goal is that one code base should be able to compile with both Scala 2 and Dotty, and that you don't have to manually change a lot of your code to get it to compile with Dotty. So drop features. So you might be interested in knowing what features will not be part of Dotty, because you can already start changing your code to avoid using these features. The first is macros, but to be more precise, Scala 2 macros, because Scala 2 macros, as they exist, are very tied to the compiler internals, which means that we can't implement them in a new compiler without a lot of work. And even then, it will be very incomplete. The proposed solution to this problem is a new macro system, which is called ScalaMeta. You can go to the scalameta.org website to learn more about it, which should be easier to use and more type safe and higher level. And ScalaMeta should support both Scala 2 and Dotty. So far, the main implementation is for Scala 2, and there is an experimental implementation for Dotty. Procedure syntax. So this one is very simple. Previously, you could write this, so a method with only a bracket to open the method declaration, and instead you should write this. So just put an equal sign, and then you can or you're not obligated to, but you should probably put the return type of the method and not let it be inferred. For some, so this is actually a pretty rarely used feature of Scala, so I won't go into too much details, but basically you cannot use this syntax anymore, array T for some type T. And in most of cases, you can instead use wildcards, which means that you can write an array of something which is a subtype of foo, which is completely equivalent. So there are some use cases for some that cannot be written that way, but they are very rare. New features, so that's the cool stuff that you can already use now because it's part of Dotty and you can already try it out. One of them is improved type inference. So here's an example of two functions which look very similar, except that here you can see that the one takes two parameter lists and the second one takes one parameter list with a comma. And you might expect them to work the same way, except that type inference works differently in Scala 2, and the second line up to won't compile here unless you put a type annotation on the lambda parameter. But in Dotty, both of these things work the same. Again, there's a lot to be discussed here, but I recommend you to go watch this other talk, which is online, which goes into more details into our work on improving type inference. Functions with very many parameters. So this one is something that people sometimes bump into and can be very frustrating, that in Scala we have classes function 1, function 2, until function 22, which means that if you have a function with more than 22 parameters, you're screwed. So in Dotty, we have introduced something called function XXL, which works for anything which is bigger than 22, and which works by taking an array of parameters, but that's an implementation detail. We have the same limit on tuples, but this is not fixed in Dotty yet, but in the future we also want to remove a limitation on tuples in the language. Intersection type. So this one, is something that you cannot fix in your Scala 2 code now, but it's already good to know about it, that we introduced a new form of types, which is A and B, when a type has both type A and type B. And so this replaces the type A with B, which is very, very similar, but A and B is more general and has works better than A with B. So just keep that in mind. The other more interesting feature is the dual of intersection types, which are union types. So a value has type A or B if it has type A or type B. For example, here we have some conditionals that returns either 1 or test. So it has type 1, it has type, in Scala 2 it has type any, but in Dotty it has type int or string. This is useful because after that you can do something like pattern matching on this union, and if you miss a case or if you add too many cases, you will get a warning from the compiler. Trait parameters. So to explain trait parameters, I'm going to go through a detailed example. So suppose that you have some trait which has some field x, and then in the initializer of the trait, you try to print this field x. And then you have some class which extends this trait, and you call new b. You might expect it to print b, but instead it's going to print null. And the reason for that is that the initializer of the trait is going to be run before the value is assigned the value b. In Scala 2, you could work around this by using early definitions, which means that you could write class b extends something, and then the trait you're extending. And so this feature has been dropped from Dotty, and instead the recommended way to do things is to use trait parameters, which are very simple. They work just like class parameters. Instead of putting a val in your trait, you can put a constructor argument in your trait, and then when you do class b extends a with value b, it will work as expected. So this feature is most likely coming to Scala 2.13, which means that you will be able to make it work in both Dotty and Scala. Proposed features. So this is more experimental stuff which has been either designed or just thought about. The first one is enums. There are non-reliable types, effect system, and generic programming, a bit like what Shapeless provides. So I will go into some of details of some of these proposals. The first is enums. So enums is just syntactic sugar for things that you would usually do using case classes and sealed threads. So you can use enum when you need something like a Java enum, but you can also use it when you need something more like an algebraic data type. So here, const and nil are case classes, and they extend list. Non-reliable types. So this one is not implemented yet, and we are still very unsure how this is going to look, but just to give you an idea, as you know, null has type null in Scala, and null is a subtype of every non-value class. So null is a subtype of string, of any of all of these things. And the idea is to make null a subtype of no other type, which means that you can't assign null to anything anymore. So how do you do it then? You use union types. This syntax is a bit long, so you'd probably want to have some sort of syntactic sugar. So you'd write string question mark to mean string or null. Of course, there's a lot of questions of how do you deal with Java interoperability and that kind of things, which we haven't yet resolved. So I'm nearing the end now, and I want to say that so Dotty is a very open and friendly community. You can go to the website to learn more about it and join our Gitter chat to ask us questions. If you want to contribute to help us, the simplest thing you can do is try to compile your own project with it and report any issue you find. You can also test our IDE support when that gets released, which will be soon. And you can also look at all the issues in GitHub that we have marked help wanted. And one thing I want to say is that there are many things that can be done to make the compiler better, even if you're not an expert in compilers, because a lot of compiler design is also about user experience. And so if you're good at user experience, then you can help us make the compiler better. Thank you very much.
どうもありがとうございました。それでは皆さんの方から何かご質問のある方いらっしゃいますでしょうか。時間割とたっぷり残っているので、たくさんお話さらに伺うことできそうですけれども。あ、どうぞ。Please use mic.
Hello. Just out of curiosity, what is an example of a use of for sum that you couldn't rewrite with a wildcard?
Good question. If you have an array of t for some type t, that is different for some type t, which is a subtype of some other type, that is different than an array of underscore subtype x, because in one case, all the underlying arrays have to have the same existential type t, and in the other cases, it can be any.
Okay. Thank you.
ありがとうございました。他何かご質問ある方いらっしゃいますでしょうか。マイク通す必要があるので下まで降りてきていただいてよいですか。すいません今2階から移動していただくので皆さんしばらくお待ちください。2階にもマイクあった方がいいですね。その振り返りの時に言っておこうと思います。
Sorry about that. I'm curious that how should I distinguish trait parameter or normal class? So when to use trait with parameter to inherit, or when to use when to inherit normal class in some case?
You should use trait parameters if they make your code simpler. So you cannot use trait parameters everywhere because they have some restrictions compared to class parameters, because multiple classes can extend the same trait, but you can only assign a trait parameter value once. So if you look at the description of trait parameters on the website, there are some restrictions. And if you can follow this restriction, then you should probably use trait parameters. Yeah. But it's a design decision in the end.
Okay, thank you.
はい、ありがとうございます。他何かご質問のある方いらっしゃいますでしょうか。大丈夫そうかな。はい、では最後もう一度搾取お願いします。ギヨムさんありがとうございました。Thank you very much.